Welcome, my friends! Today we will be discussing the hypothesis test for two independent population means using p-values. By independent, I mean that the observations from the first population have no impact on the observations from the second population. Examples might include data gathered from different schools or from different cities. The goal of the two-sample mean test is to determine if the mean of population 1 is greater than, less than, or different from the mean of population 2. For a left-tailed test, we believe the first population mean is smaller than the second, indicated by a less than sign in the alternative hypothesis, and the p-value will be in the left tail of the distribution. For a right-tailed test, we believe the first population mean is greater than the second, indicated by a greater than sign in the alternative hypothesis, and the p-value is in the right tail of the distribution. For a two-tailed test, we believe there is a difference between the two population means, but we aren't sure which one is larger, indicated by a not equal to sign in the alternative hypothesis, and the p-value is the combined area in both tails. Note that the size of the p-value will vary based on the data, although I've drawn distributions showing relatively small p-values. Now, sometimes you will see an alternative way of writing the null and alternative hypotheses, with mu1 minus mu2 on the left-hand side and 0 on the right. This way is equivalent and is desirable if we might want to replace this 0 with some other number. For example, maybe instead of just thinking that there is a difference between mean 1 and mean 2, we think that mean 1 is larger than mean 2 by at least 10 units. Then we might use this setup for the hypotheses and replace the 0 with a 10. For our purposes, we will be using the first form of the hypotheses, and will always assume that the hypothesized difference is equal to 0. Let's talk about the assumptions of the two independent population mean test. There must be a quantitative variable gathered from two independent groups, with population means mu1 and mu2. Randomization must be used to gather the data from each group. If the distribution of each population is approximately normal, any sample size will work. Otherwise, the sample size from each group must be at least 30. Note that the sample size from group 1 does not need to be the same as the sample size from group 2. If the population standard deviations are known from both populations, which is unlikely, we will use the z-distribution. Otherwise, we should use the t-distribution. If the t-distribution is used, we must also determine whether or not the population standard deviations of the two populations are equal, in which case we will use the pooled t-test, or if they are unequal, in which case we will use the unpooled t-test. So as you see, there are actually three different options: a z-test, a pooled t-test, and an unpooled t-test. We will only be covering the unpooled t-test in this video, as the z-test carries an unlikely assumption of known population standard deviations, and the pooled t-test is a little bit computationally intensive and less commonly used. I would still like to show you the test statistic for all three tests, which we will look to now. Case 1 is the z-test, which should be used when the population standard deviations are known. Here is the test statistic. If you haven't caught on already, values with a subscript 1 correspond to the first sample, and values with a subscript 2 correspond to the second sample. As it is unlikely that the standard deviations will be known, we will not be showing the z-test procedure in this video. Case 2 is the unpooled t-test, which should be used when the population standard deviations are unknown and assumed to be unequal. The test statistic is the same as it was in the z-test, except we substitute s for sigma. The degrees of freedom should technically be calculated using this formula, which is a little bit complicated, but the degrees of freedom can be conservatively estimated by the smaller of n1 minus 1 or n2 minus 1. Case 3 is the pooled t-test, which should be used when the population standard deviations are unknown but assumed to be equal. This can be verified with an additional hypothesis test, which we won't be covering in this video. Here is the test statistic. In order to use this procedure, you must calculate a pooled estimate for the standard deviation using this formula. The degrees of freedom in this case are n1 plus n2 minus 2. Note that sometimes you will see an additional term in the numerator of any of these three formulas, such as minus mu1 minus mu2, or perhaps minus delta sub 0. This part is necessary if you are testing a difference other than 0, as we talked about earlier, but for our purposes, we do not need this additional term. We'll be focusing on the middle case, which is the unpooled t-test, but just know that there are two other approaches that might be appropriate depending on the circumstance. Alright, let's look at an example. Do American men weigh more or less than Canadian men on average? A random sample of 49 American men and 64 Canadian men found a mean weight of 198 pounds for the American men with a standard deviation of 25, and a mean weight of 187 pounds for the Canadian men with a standard deviation of 20. Is there sufficient evidence to conclude that there is a difference in the mean weight of American and Canadian men? Use a 0.05 level of significance. Let's begin by listing some of the given information. We can let sample 1 represent Americans and sample 2 represent Canadians. N1 is the 49 Americans that were sampled. X bar 1 is the sample mean of 198 for Americans, and S1 is the sample standard deviation for Americans, which is 25. N2 is the 64 Canadians that were sampled. X bar 2 is the sample mean of 187 for Canadians, and S2 is the sample standard deviation for Canadians, which is 20. Now we can move on to step 1 of the hypothesis test, which is to check our assumptions. Do we have a quantitative variable gathered from two independent groups with population means mu1 and mu2? Yes, the quantitative variable is weight. Mu1 is the population mean weight of American men, and mu2 is the population mean weight of Canadian men. Was randomization used to gather the data from each group? Yes, the problem states that we took a random sample. Is the distribution of each population approximately normal, or are each of these sample sizes at least 30? The sample size is above 30 for both samples, so the central limit theorem applies, and the difference in sample means will follow an approximately normal distribution. Are the population standard deviations known? No, we only have the sample standard deviations. We will assume that the population standard deviations are not equal and move forward with the unpooled t-test. Step 2. The null and alternative hypotheses. For the difference of two population means, the null and alternative hypotheses contain mu1 and mu2 with some symbol in the middle, which we will determine based on the wording in the problem. If we reread the given information, we see the research question is whether or not there is a difference in the mean weight of American and Canadian men. Nowhere in the given information is there a suggestion that the mean of one population is greater or less than the other, so therefore we have a two-tailed test, meaning we need to have not equal to in the alternative hypothesis and equal to in the null hypothesis. Step 3. Calculations. We must calculate the unpooled t-test statistic using this formula. Plugging in, we have this result. On the TI-84 calculator, we type open parentheses 198 minus 187 close parentheses divided by the square root of 25 squared divided by 49 plus 20 squared divided by 64. When we press enter, we get the test statistic of approximately 2.52. If we draw the graph, the test statistic of 2.52 is on the right side of the distribution. But since we have a two-tailed test, indicated by the not equal to sign in the alternative hypothesis, we must also plot negative 2.52 on the graph. The p-value is the combined area of the two shaded regions. To find the p-value on the calculator, press second, distribution, option 6 for TCDF, and then we can choose to solve for either the left or the right tail. Let's do the right tail. The lower bound of the shaded region is 2.52, and the upper bound is positive infinity, which we can enter in as 1000. The degrees of freedom can be approximated by the smaller of n1 minus 1 or n2 minus 1. 48 is smaller than 63, so the degrees of freedom are 48. Scroll down and press paste. On a TI-83 calculator, match this output. TCDF 2.52, 1000, 48. Press enter and we get about 0.00756 rounded, which is the area in each of the two tails. The combined two-tail area is this number multiplied by 2, which is 0.0151 and is our p-value. This is also the combined area in the two tails. Step 4. Decision. If the p-value is less than or equal to the level of significance alpha, then we reject the null hypothesis, and if the p-value is greater than the level of significance, we fail to reject the null hypothesis. Like I like to say, if the p-value is low, the null has to go, and if the p-value is high, the null will fly. In our case, the level of significance is 0.05, and the 0.0151 p-value is less than the 0.05 level of significance. The p-value is less than or equal to the level of significance, so we reject the null hypothesis. The p-value is low, so the null has to go. Step 5. Conclusion. Our conclusion is that, at the 5% level of significance, there is enough evidence to suggest that there is a difference between the population mean weight of American and Canadian men. And we are done. Alright, my friends, that wraps up our discussion of the hypothesis test for two independent population means using p-values. We will be exploring many more fun and exciting statistical topics that you won't want to miss, so make sure to check out our other videos.